Hello. Real quick. Additive relationships, additive relationships, additive relationships. Our equation is y is equal to x plus b. Our b is our y-intercept on our graph, the point where my line crosses that y-axis. Today, however, we are going to be talking about multiplicative relationships. Again, the things that I'm writing down here, you don't need to write down anywhere. You're just watching to see what I'm talking about. So on the next page, you'll understand what that looks like. So in a multiplicative relationship, I'm going to be multiplying a number times my x. Not my ex, though, my husband. Hi, Mr. Arnold. So in a multiplicative relationship, your equation is going to be in the form y is equal to mx. Y is equal to mx. What's different about a multiplicative relationship compared to additive? Additive was non-proportional. It did not go through the origin. But multiplicative relationships do go through the origin. In case you forget, the origin is that point right there on my graph. Multiplicative relationships go through that line. So my line would look something like this, where my line goes through the origin. My line goes through the origin because I'm not adding or subtracting anything. I'm just multiplying times things. Something that is a little bit different is this letter M that we call the slope. The slope is how we know how much we move between points on our graph. So I like to call them corner points or pretty points. And the origin is one of these points that's going to help us find our slope, help us find this number. The slope is that number that we multiply over and over again to help us with our equation. All of these corner points, all these pretty points are going to help us find the slope, and we're going to talk more about that today. So no, multiplicative relationships, we're multiplying or dividing, and my graph is going to go through the origin. So on this notes page now, let me get a different pen so you can see it better. Purple. Slope is a rate of change in a proportional relationship between two quantities. Again, proportional relationship means it goes through the origin. We have a lot of words for slope. A lot of words for slope. Again, in my equation, my m means that is my slope. But other words we have for it are the constant. Sometimes we call it a unit rate. Sometimes we call it the constant of proportionality. Sometimes we call it the rate of change. There's a lot. Oh, Andrea, the coefficient. We learned that word already. The coefficient. We have a lot of words for this m, a lot of words for the slope, because in math, it's a big topic. We see this number a lot. And so because of that, we have a lot of different words for it, for different situations. But any of these words mean slope. Pause the video, make sure you get those written down. We need to know all those words. Once you've gotten all those things written down, let's go ahead and take a look at some examples where we're trying to find the slope in our equations. So like we said earlier over here, our slope is the number that we multiply times our x. We take our slope times our x. So what number is in front of my variable? What's my coefficient? So in example A, our equation is y is equal to 2x. What is my slope? What is my m? What is my number in front of my x? 2. In that equation, my slope is equal to 2. Example B, what is your m? What is your slope? What is your constant here? Here my slope is 1/2. And this takes me into how these multiplicative relationships could also be dividing. If I take 1/2 times x, that is the same thing as y is equal to x divided by 2. Oops. Multiplying times 1/2 and dividing by 2 are the same thing. So yes, you may see an equation written like this, y is equal to x divided by 2, but that's a multiplicative relationship because I could also write it as 1/2 times x. So know that those two things go together, they're the same. Let's take a look at some examples that we have where we're finding the slope in our equation. So on number 1, we have y is equal to 4x. What is your m? What is your slope there? 4, the number that's in front. 2, y is equal to 3/2 x. What is your m? What is your slope there? Remember, that slash like that means a fraction bar. So here our slope, our m, is 3/2. Or you could also write it that way, 3 fraction bar 2. Either one of those ways works. Number 3 is tricky. What is your slope in 3? We talked about this before with inequalities and equations. If there's no number in front of x, there's an invisible 1 that we just don't want to write there. So if you don't see a number in front of the x, that means your slope is just 1. That means your slope is just 1. Number 4, you've seen that before. What is your slope on number 4? 4. In Foundations of Algebra, in this math class, your slopes, the ones that you're going to see in our class, are positive only. Again, with each grade level, math gets a little more tricky. Next year in pre-algebra, you'll see that there's a 0 slope. You'll also see that there is negative slope next year in pre-algebra. When you get to algebra, you'll still see positive and negative slope and 0 slope, but you'll also have undefined slope. So again, each year just gets a little trickier, but this year, since it's new, we're just introducing it to you. You're only going to see positive slope type questions. Pause the video if you need to write any of that down. Otherwise, let's go back to the note side and talk about finding slope in a table. So now when we're finding slope in a table, to calculate our m, our unit rate, our constant proportionality, our rate of change, our coefficient, we have a formula to help us figure this out. We need to turn this into a fraction. We're going to take the changes in our y's for our numerator and put the change in our x over our denominator. The way that things change from one point to the next on my table. How things change from one to the next on our table. So if we take a look here, on my chip side, I go from 1 bag of chips to 2 bag of chips. So how did our numbers change? We added 1. We increased by 1. Over here, our cost for 1 bag of chips was $2.50, and then it went up to $5. How much did we add for each bag of chips? We added $2.50. So for me to calculate the slope, I need to put the change in my y over top of the change in my x. So in my fraction, it's the change in our y over the change in our x. Remember how we talked about math people work smarter, not harder? The way that we show change in math, instead of writing out the word change of, we like to draw this triangle. This triangle means change. And the way that we say that symbol, we call that symbol delta. It's like in COVID, you guys have heard of the Delta strain. It's based off of that Greek symbol, that Greek letter delta. So delta y over delta x, the change in the y over the change in the x. Here, my y change was $2.50. My x change was 1. So my fraction I get is 250 over 1. Where things get a little tricky here is I want to simplify my fraction, if I can. In this situation, because my denominator is 1, my numerator is my number. My numerator becomes $2.50 for my slope. My numerator becomes $2.50 for my slope. So now if I want to turn this m into an equation, remember our equations are in the form y is equal to mx. Y is equal to mx, my slope times x. Here, my slope was $2.50 times whatever x value I got. So my slope here, or my equation here, excuse me, is $2.50 times x. Let's take a look at the next one. So now we're looking at candy and the costs. So I'm looking at my x's. How much do I change when I go from 1 to 3? I added 2 to go from 1 to 3. How much do I add to go from $1.50 to $4.50? How much money did I add? I added $3. So now I want to find what is my slope and then make the equation. To calculate slope, remember it's the change in my y over the change in my x. Delta y over delta x. What was the change in our y? Our y change was 3. Our x change was 2. So the fraction we get here is 3 halves, or 3 over 2. I can't divide 3 and 2 by any number to simplify it. So that means it's already in simplest form. So when I'm writing my equation, again, it's in the form y equals mx. My m, my slope here, is 3 over 2. And I just need to take that times x. So my equation here is equal to 3 halves x. Go ahead, pause the video, finish writing any of that down if you need to, and please ask us any questions that you might have. This slope topic is huge, huge, huge for the next few years of your mathematical career. It's important that we ask questions when we have them. What's cool about proportional relationships is this pattern that you see continues for the whole table. So again, 3 plus 2 gives me 5. 5 plus 2 gives me 7. I keep adding 2 each time. Here, 450 plus 3 gives me 750. 750 plus 3 gives me 1050. Your table won't always increase by the same amount, but this relationship of 3 to 2 will always be there. Will always be there for you. Let's flip to the back side and do some example problems finding our slope on our tables. So again, our slope is delta y over delta x. A delta y over delta x, change in y over change in x. So looking at my table, how do I go from 1 to 2? I add 1. And then on this side, how do I go from 6 to 12? I add, ooh girl, I had 6, not 12. I got excited. Come here, white out. Have y'all ever seen like the posts on TikTok where it's like you had one job? I was making this video and I did all the graph on the bottom part, but I forgot to hit record. Yay! So I'm going to do it again. And it's going to be better than the last one, so don't you worry. So now we're doing slope on a graph. It's the same thing. slope on the graph, the vertical change over the horizontal change. If we think about our axes, our vertical axis is the y-axis. So the vertical change is the change in your y. See where this is going? And then your horizontal change, your horizontal axis is your x-axis. So it's the change in your y over the change in your x. It's the exact same thing that you were doing in your table, but it's just now it's on a graph. Change in your y, change in your x, change in your y over change in your x. We do have a saying that helps us out just a little bit more than having to remember which is my x-axis, which is my y-axis for graphs. For graphs, what we say when we're going to find the slope, we're saying that we're looking for the rise over the run. If something rises, what direction does it go? It goes up. If we run, what direction do we go? To the side. So we're seeing how far we're going to go up, like on our x-axis. And we're going to see how far we run, like on our x-axis. How far we go up and how far we go over. So we want to go up and over our rise and our run between those points I was talking about earlier, those pretty points, those corner points. Again, this is already written on because I already made the video for it, but I forgot to hit record. So this point right here, this is not a corner point. This is not pretty. If I'm trying to read this number, I know it's between 0 and 1, but I don't know exactly what number that is. I know this is 1, but I don't know for sure. So I don't want to use a point like this. This is not good. I want to use a point like here or a point like this. Because here I can see clearly that this is at 1. This is clearly at 2. So when I'm talking about pretty points, I'm talking about these corner points. I can read them exactly. On your graphs, you're going to find there's more than one pretty point, more than one corner point, but you only need 2. You only need 2 points to find a slope. So if I take a look at my graph, the way I like to do it is I just like to go on it from left to right, just like we read from left to right, go from left to right until I find some pretty points, my corner points. So if I go, oh, I see that this here is a pretty point that I can take a look at because it's on the corners. If I keep going, I see, oh, my origin is also a pretty point that I can use. I could use this one, I could use this one, I could use this one, this one. There's a lot of pretty corner points on this one. But again, I only need 2 to find slope. I need to do my rise over my run between those 2 points to find my slope. So I'm going to write my fraction bar, and I'm going to see first, how far am I rising? To go from this point to this point, I have to go up and over like I'm driving a car. I can't go through the middle of a block when I drive. I have to go up and over. So that's how we count. So to go from this point to this point, I first have to go up. And I go up 1 space. So here my rise, my numerator is going to be 1 because I went up 1 space. Now I need to run. And if I run, I see, oh, I'm also running 1 space. So my denominator is also going to be 1. I went up 1, I went over 1. So my slope is 1 over 1. What does 1 over 1 simplify to? Just 1. Just 1 there for my slope. So in my equation, again, it's in the form y is equal to mx. M for multiplicative. That's how I know which equation it is. My multiplicative relationship is y equals mx. My m here we just calculated to be 1. So I could write it as y is equal to 1x, or us lazy math people, you wouldn't write that 1 there because 1 times x is just x. So a way that you would actually probably see this on a test is just y is equal to x. Just y is equal to x. Rise over run on a graph. Rise over run on a graph. So now we've got a new one. Tell me when to stop when you see a pretty point or a corner point? Here's one. That's not pretty. It's not on the corner. It's very close, but it is not pretty. Same thing here. Not a corner point. Here's a corner point that we can use. If I keep going, I see there's another one here. So here there's 3 corner points that we can use to help us find our slope. But again, how many do I actually need? I only need 2 points to find my slope. I only need 2, so I can do my rise and my run. My rise over my run. So let me put my fraction bar in there. And let's see. To go from this point to this point, I'm going to rise. I'm going to go up. And I have to go up 1, 2 spaces. Count the spaces, not the lines. Count the spaces, not the lines. It gets a little tricky if you try to count lines. So I went up 2 spaces. And now I have to run. Now I have to run this way to my other corner point. So I'm running 1, 2, 3. So my denominator would be 3. That fraction, 2/3, that's not going to simplify pretty for me. So that means that that's my slope. I don't have to do anything extra. So then I'm writing my equation. I just substitute my slope in for my m. So my y is equal to 2/3 times x. 2/3 times x. Pause the video if you have any questions on this for us. This topic is huge in pre-algebra. It is huge in algebra. You're going to be seeing slope for literally the rest of your mathematical career. It never goes away. So it's important that you ask questions now if you have them. Otherwise, if you're good, let's flip to the back side where I realized that I wasn't recording yet and do the graph examples down at the bottom. So number 9, isn't this so nice? They put the pretty points on there for us that we can use. We didn't have to find any. If you want to find your own, it looks like there's one on the origin too. It also looks like there's one up there if you want to use one of those ones instead. But it doesn't matter which ones you choose because you're going to get the same answer either way. So, how do we find slope on a table or on a graph again? Graph is rise over run. Our table was delta y over delta x, change in y over change in x. Here it's rise over run. Same thing, we just say it differently because they look different. So my rise between my 2 pretty points, again, I'm like a car. I have to go up and then I have to go over. So here I'm going up 1, 2, 3, 4, because I need to get to the same level as that dot. My rise was I went up 4. Now my run is how far I'm going to go over. I went over 1, 2 spaces. So my slope is 4 over 2. Now I need to see, can I simplify that 4 over 2? Yes, I can. What number can I divide into 4 and 2? 2. I want to simplify my fraction. 4 divided by 2 gives me 2. 2 divided by 2 gives me 1. So 4 over 2 simplifies to 2 over 1, which then simplifies to 2. Or maybe you just did 4 divided by 2 and got 2 that way. You'll still get the same answer. So our equation for this graph, in the form y is equal to mx, what would my equation be? Y is equal to 2x. Y is equal to 2x. Again, like I said, you can choose any set of pretty points. You could choose this one here and this one up here. And you get that your rise is 1, 2, and your run is 1. So you still get 2 over 1, which would give you the same slope as 2. That's what proportional means. It's the same relationship over and over and over again. We're multiplying the same number over and over and over again. Oh, I forgot to show you guys that on this too. So again, I'm multiplying the same number over and over and over again. So 1 times what gives me 6? 1 times 6 gives me 6. 2 times 6 gives me 12. 3 times 6 gives me 18. 4 times 6 gives me 24. It's a little bit harder to see over here with the decimals, but 1 times 14 gives me 14. 1.5 times 14 gives me 21. 2 times 14 gives me 28. Proportional means you're multiplying the same number over and over and over again. So if you don't like this change in y over change in x, you can also just try figuring out what number am I multiplying over and over and over again. Sorry I forgot that earlier, but I'm glad I remembered it now. All right. I want you to pause the video, and I want you to try to do the rise over the run yourself. Try finding the slope between these two pretty points that they gave you. Try finding the slope on those points on your own. Pause the video. Good luck. Hopefully you saw that the slope was 6/4. I went up 1, 2, 3, 4, 5, 6. My rise was 6 because I went up 6, and then I ran 1, 2, 3, 4. My run was 4. If you did not yet simplify it, 6/4, I can simplify that fraction. Think what number divides into 6 and 4 evenly so that you can simplify that fraction. Try it on your own. They both divide by 2, so your slope here is 2/3. If you got any of that wrong, make sure you go back and fix it. And then I want you to write down the equation. So go ahead, pause the video, try the equation for me. Hopefully you got that the equation is y is equal to 2/3 x. I tried that TikTok transition that I did the other day, and I think it went okay. Let me know. Maybe I need to pause a second before I lift my hand and stuff. Feedback is welcome. So y is equal to 2/3 x. Just like with additive, that's the different ways that we can see it. Now we can also read these relationships as well. A seahorse can move at a constant speed of 0.5 miles per hour. What's a keyword there that tells us this is going to be a multiplicative relationship? What's a keyword there? Per means to multiply. So that means that our equation is going to be y is equal to my slope, that's 0.5 that I multiply over and over again, times x. Oh, girl, I wrote that over here. Y is equal to 0.5x. Our m, our slope, is that 0.5, that number we multiply over and over and over again. Try number 6. A lemon tree seed is planted and the tree grows 2 feet per month. Write the m, write your slope, and write the equation for me. Again, that word per means to multiply. I'm multiplying that 2 over and over and over again. So my equation here is y is equal to 2x. I know this was a long set of notes, but again, this topic is huge for all of your math classes to come. If you have any questions, please, please, please let us know. We're about to do some more practice with this, so please check in with us to make sure you're ready to move on to the next one.